Okay, so we need to talk about basic integration techniques. They're not technically basic in that they're super simple. They're just things that you try when you look at the problem, and off the top of your head, you don't necessarily know how to integrate them. Everything in the assignment you're going to do, you technically should know how to do, but sometimes people forget, so we're going to talk some basic strategies. So one thing that you often try is you want to expand where you're multiplying everything out. You only want to do this with the numerator. You never want to go about expanding a denominator. That tends to make things worse. So an example of that is if you're integrating, say, 3 minus e to the x squared. If you're trying to pick out u's and du's the way that it's written now, you can't, because your du wouldn't be there, because your u value would be this, and then du would need to be negative e to the x, which doesn't exist. So what you have to do is you have to square it first, not where you square them individually, where you write it twice and you do FOIL. So when you do that, then you'd be looking at 9 minus 6 e to the x, and then you'd have e to the x times e to the x, which would be plus e to the 2x. And then you have a sum or a difference, and you can integrate all of your pieces separately. So like 9 would change into 9x. E to the x is the exact same thing. And then for this last one, your u value would be 2x. So then your du value would be 2. And remember, you can write that down if you're not doing it in your head. So then you're missing a 2. So you put in the 2, you pull the 1/2, and then you have e to the u du, which integrates to be e to the u plus c. So another thing that you sometimes can try is separating the numerator. And a lot of these things that we end up doing, you'll notice, are inverse trig functions, because the trig functions are the ones where you often have to do super, weird stuff. So say you've got 1 plus x over 1 plus x squared. If you pick out your u value to be the bottom part, the top part would need to be 2x, so the 1 really is not helpful. So what you want to do is you want to separate it. So then you'll have 1 over 1 plus x squared, and you integrate that, and then you have x over 1 plus x squared, and you integrate that as well. So here, the 1 over 1 plus x squared is an inverse trig function, specifically it's arctangent, where your u value is x and your a value is 1. So arctangent is 1 over a, but a is 1, so it's just 1. And then you've got arctangent of u, which is x over a, which is 1, which don't write that down. So then here, your u value would be 1 plus x squared, so then du would be 2x. So you'd put in the 2 and pull the 1/2. And then you have du over u, which is natural log of the absolute value of the bottom, plus c. So a third thing that you often or sometimes want to go through and do when you are trying to integrate is you sometimes need to complete the square. And again, this often but not always happens with inverse trig functions. So if you've got 1 over 4x minus x squared, if you complete the square down here, you would take the negative out, and then take the negative 4, divide it by 2, square it, and then this is what you add into the problem, but technically you put a minus 4 into the problem, so then you want to take a positive 4 out of the problem so that you've technically done nothing. And then after you've done that, what you're looking at underneath your square root, and I don't have that much space, so I'm going to get rid of it, is you've got 1 over, you've got the square root of then 2 minus, and then this is going to be x, and the after you've divided by 2 number, and by 2 I mean 4, sorry, 2 squared dx. So then same thing, this ends up being arcsine, where your u value is x minus 2, so then your du value is just 1, so that's good, and then your a value is 2, because you need to square root 4. So arcsine, remember, is the only one that doesn't have the 1 over a in front. So then you just have arcsine of u over a, which is 2 plus c. All right, so 2 more things. And I'm leaving the title here the whole time, mostly because I can't write at the very top of the board, and that sort of gives me a stop writing here spot. So next thing that you often try is long division. We've talked about this, but I'm saying it again. You need to make sure that you do long division when your top power is either the same or bigger than the bottom power. Every single time you should start out by doing long division. So doing long division here, the top goes inside and the bottom goes outside. So x squared goes into x squared once, you'd multiply through, so then you have x squared plus 9, draw, flip, add, so then you've got negative 9, which is your remainder, which goes over x squared plus 9. And then really, because it's a sum or a difference, you have 2 problems. So you'll integrate 1, which is just x, minus here, when you go to integrate. This same thing is an arctangent problem. So the 9, if you throw an integration symbol in here, realistically is stupid. So you would take it out. And then what you have is you have your u value being just x. So then du is 1, which we have. And then your a value would be 3, because that's the square root of 9. So with arctangent, you have 1 over a in front. So you'd have 9 over 3, which is going to be 3 arctangent of u, which is x, over a, which is 3 plus c. So the last thing that we need to talk about, or it's not really a thing, but the last technique that you often try is sometimes you have to add or subtract stuff into your numerator. Usually what you're adding and subtracting in is a constant. You don't add or subtract in x's very often. I guess every once in a while, but it doesn't happen a lot. So if you're picking out u's and du's, your u value would be the bottom part. So then your du would be 2x plus 10. And you say, I don't have 2x plus 10, I have 2x. So that's when you put stuff into it. So you want to add in the 10 so that you have what you need, but you can't just randomly put in a 10 without undoing it. So you would also take out a 10 and then you can whack the thing into 2 pieces. So then you'd have 2x plus 10 over x squared plus 10x plus 25. And minus the 10 is not helpful. You've got 1 over, and then back here, you could think of it as completing the square, but really x squared plus 10x plus 25 factors. So you could complete the square like we did in the earlier problem, or you could just factor it, because if it factors, it's x plus 5 and x plus 5, so then it's x plus 5 squared here. So then here, u du, which means it's going to be natural log of the absolute value of the bottom. And then this one, although it usually ends up being arctangent when you split it up, this one is not arctangent because you don't have the extra constant floating around. So here your u value is just x plus 5. So then your du value is 1. And you're integrating u to the negative second. So then you just add and flip. So then you end up with positive 10 and u to the negative first, which means this is on the bottom, plus c. And then those are your basic integration techniques. Thank you.